Hi everyone, I'm very happy and I want to thank Toloka for this opportunity to present our work. So I'm going to speak today about estimating the Twitter mDAU. So unless you lived under a rock, then you know there is interesting internet drama going on in the last few months. So Twitter was about to be bought by Elon Musk, and then suddenly he canceled, or he tried to cancel the deal. It went to court, and currently he's trying to rebuy the deal. So there's a lot of ongoing drama, and what the idea behind this notion or question or what underlies the problem is something that Twitter calls mDAU. And mDAU, they defined it in their financial reports, is monetizable direct daily active users. And these users are actually what Twitter sells to their advertisers. So these are the people that are logged into Twitter and they engage the platform and use it. And this is directly tied to the financial worth of Twitter. So what's in dispute is how prevalent are bots on Twitter. And I want to make a distinction here. There's a lot of friendly bots in Twitter that do things that you want, like you subscribe to something, they inform you of your favorite show coming on or whatever. But there's also a lot of scammy or unfriendly bots in Twitter. And the issue of how many of the accounts on Twitter are actually bots are in dispute. So Twitter officially states that something like 5% of their users are bots, and this is due to a very extensive effort they're making to delete accounts and check the identity of or the activity of the users, and this is the figure that they state in their financial reports. However, there were several works. One of them I'm using the slides from that state that actually it's closer to 20% of the amount of users in Twitter are bots, and there's some discrepancy here, and this is about money. This relates to money. So before I described our project, I want to introduce us, Similarweb, a bit. So we're an Israeli-based company, and our goal is to give all information digital about websites and applications. So this is something we are called digital intelligence, and it has to do with the number of users going to a site, keywords related to site, and new products include products you can buy on Amazon. So the idea is that we sell data. So we are a company that our product itself is data that we are selling. This is an example of something that we are supposed to predict. This is the website traffic of NFL.com. As you can see, this is an interesting quasi-periodic signal, and it's a very staple of our the challenge that we are trying to overcome. And so we do a lot of models that pertain to time series analysis, and we use a lot of data that we call so-called structured data. Okay, and this is another example of Apple.com. So we need to be able to differentiate between an actual signal, an event, a news event, or an actual event in the real world, Apple launching a product, and something that is like noise or an artifact of our models. So the main two data sets that we use, something what we call the learning set, is just direct measurements from our customers. And these measurements are few and also biased in the regards that we don't have good coverage of all countries, we don't have good coverage of all sizes, of categories of websites. So this is another challenge that we need to overcome. And another source of data that we have, what we call the user panel, is not dissimilar to what Toloka offers, is a large group of users that share with us information, and we rely on this information to estimate, to generate the estimations. Okay, and for those of you who are more data science oriented, so two unique problems that we have that most other companies do not have is something called source consensus, that we have data coming from very myriad of sources. All of these sources have different biases. We need to come up with some sort of model that ties all these models together and decide from all these different competing suggestions for estimation, a certain estimation. And another thing that we struggle with is that we have data on the user level, but we only have learning set on what we call the bag level or the site level. And this is a very soft loss term. And there are many ways to solve our models giving these soft losses. And these are the two, like say, mathematically or algorithmically heavy challenges that we need to tackle. Okay. So coming back to the Twitter project, so our goal was twofold. One, to generate an actual estimation of Twitter mDAU, which they stated that is impossible to do. And the other goal was to resolve the contradiction between what the Twitter report and what what was reported by SparkToro and others about the fraction of bots in Twitter. So I just want to make sure that we're on the same page. We didn't set up to estimate the number of bots. Other people have done this. I recommend, if you have the time and the inclination, you can go and try to read through their works. It's very interesting. People have very different approaches. They looked at the text that the people tweeted, the frequency of tweeting, a whole lot of features, and they came out with interesting machine learning based models to after they scraped the tweets themselves, and to try to determine this. And this is not our goal. Our goal is actually to predict the number of real users that Twitter has. So the first thing we did, but one of our team members just verified that our panel doesn't have something that looks like a Twitter bot, and we used a bunch of heuristics. These heuristics basically say the user doesn't behave oddly, he doesn't do like a periodic calling or sampling of data, he gets to sleep at night, things like this. So we made sure, and then we saw that a very, very, very small fraction of our users were filtered out using any of these different heuristics that I just mentioned. Okay. Okay, and then our approach was very simple. We have our panel data, and this panel data, on our daily job, we built over it a very complicated and full of steps estimation models for the different websites. Here we did something, took the completely opposite approach. We wanted to do the simplest model possible, and say, because we wanted the model to be explainable and easy to understand by anybody. So it's basically a regression model built on our panel data with respect to a certain number of sites, but we made sure that both these sites and application included the largest sites and relevant social media sites such as Instagram, Facebook, and TikTok, and so we had representation of similar platforms, platforms that similar to Twitter, and then we just built a simple regression model. We see a certain traffic coming from a panel, and then we built a robust regressor to avoid outliers, and the most of the work was to indeed to validate that our model shows the numbers that were stated in financial reports, quarterly financial reports by other companies, such as Facebook. So when we saw that the numbers we are getting are pretty on the dot for those companies, we were very happy. And these are the results. So what you can see here is for the 4 quarters, starting at the 3rd quarter in 2021. This is the traffic for Twitter. So that on the top left is the app activity, and then on the bottom you have the usage from desktop and usage from mobile web. You can see that it's pretty much on the same level for these quarters. This is another interesting Venn diagram. This is the distribution of usage from more than one platform. So some people don't use only the Twitter app or the desktop. They use more than one platform, and then you can see the distribution. It's mostly the case that people are using the Twitter app, but some people are using the mobile web exclusively or the desktop, and some of them are doing more than one, using more than one platform. Okay. One thing that we had to tackle is that our panel data, actually we see users and Twitter reports accounts. So some people have more than one account, and we had no direct way or simple way to estimate this ratio. And what we did, we took a benefit of our very unique panel in the sense that we can send surveys questions to our panel, and using the results from the survey questions, we came up with the number I will show you soon. It's, what is interesting about this approach is that we know the browsing history and app usage of these users. So when we send them question, we have a very independent way to see whether they are lying. So if they're lying, they will lie about things that we know that we can verify. And this actually improves our fidelity to a very great extent. Okay, I said all this in this. Okay, so the number that we actually found out is not 1.81. I'm sorry, it's not 1.18. It's 1.13. So this means like this: the following. So some people have more than one account. A lot of them have 2, 3 accounts, but they're not active. They have these accounts, but on a daily basis, they're using their main account, and sometimes they switch to another account for, I don't know, because they work in a company, or they want to be more anonymous, or whatever. But the number is relatively close to 1. It's a factor of a little bit above 1.1. Okay, and this is the actual distribution we got from the survey. So I will explain the first bar, the 0 bar soon. But you can see most people have just one account, and the others, it follows like this exponential distribution. And but this is the effective usage of accounts. This is not how many accounts I have potentially, but this is how many accounts I actually use more than once a day. Okay, and these are the results. These are the results that we got. As you can see on the bottom line, these results agree with Twitter. So what we have is the results that are similar to what the Twitter are reporting in the financial reports. And interesting thing that we found is that what Twitter is not reporting is a lot of unauthenticated users. Now, I myself don't have a Twitter account, but I get a lot of Twitter links daily. So I can browse in the desktop or the mobile web, and I can see the tweet. And there's a significant portion of people who do this, and you can see their numbers here. It's not negligible. It's like 20% of people, and here in the next graph, you can see a breakdown of 3 groups of people. So in the blue, you have people, as I just mentioned, that don't have an account. In the green, you have people that have a Twitter account, but are not active. And the most interesting part is the orange. There are a group of people that have a Twitter account and actually do something actively. They're tweeting, they're replying, and this was the main finding for us. So take a moment to take this in. You can see that most people, and I think it should translate to your experience of Twitter, of most of you, don't tweet. They don't engage the platform, just use it passively. Okay? And this actually explains the contradiction that between the 20% reported by SparkToro and the 5% reported by Twitter. So out of the active users, this is the report that was done by the companies, because people, when they came out, they tried to analyze the fraction of bots, they used actual people that were active in the last 90 days. And out of that, this 5% that we took as is, we took Twitter's word, translate to the 20-something% of the users being bots. And if we take another work done like 5 years ago, that they found out that the bots tend to tweet about 1.5 more than humans, then this comes up almost to 30%. So this for us we were very happy about this, because this is a result of the contradiction between the two stated numbers. So these are the people that worked on the project from our team. And I think that's it for me. Thank you.